This is Hemant. In this video, I am going to solve question number 3 of Math 104 and term examination. So let's start working it on a paper now. So let's have a look at the question first. Find the motion of the mass spring system modeled by the ordinary differential equation and the initial conditions of this ordinary differential equation is given as y of 0 is equal to 1, y dash of 0 equal to 1. So they have given us a ordinary second order non-homogeneous equation. They also ask us to sketch the graph of the solution curve. In addition, sketch or graph the curve y is equal to yp. You are asked to find the graph of a particular solution also. So let's start let's examine the mass spring system first. Let's assume a mass spring system of this kind, mass m. So in this particular system, let's say this mass is experiencing some force F, sinusoidal force S sin omega t of mass m. And here in this direction, it's experiencing some force kx, and there will be some mass into acceleration. The pseudo force will also act on this mass, which is opposite to the direction of acceleration. And there might be if this is a viscous medium, it will have some force acting on it, which is negative direction of the velocity, in the negative direction of the velocity, that is minus bv. It is represented as minus bv. So let's form an equation, f naught sin omega t is equal to mass into acceleration plus kx plus bv. Here signs doesn't really matter much, it only represents direction only. So here acceleration is twice the derivative of a position. So here let's assume let y be the distance between the position at particular time t and its ground state or initial position, y is equal to 0. So this can be written as y double dash plus bv, we can write as b into y dash plus dy by dt is equal to b plus kx. So this is the general equation of all the forces acting on this particular mass spring system. So let me write the question or equation which is given in our question. It's 24 sin t. So if we compare these two equations, we can get some conclusions like m is equal to 1 and b is equal to 0. This is what so this indicates there is no damping force or viscous force acting on it. So there is so the energy of the total system is constant, so it will last ever. So there is no chance of stopping. There is no chance of this block to come to equilibrium position for this equation. So k is equal to 25. So let's solve this equation first now. So as you all know, it is a second order non-homogeneous differential equation. So the solution y will have two parts, which is now homogeneous part and yp, which is particular part. Homogeneous part, now I am going to solve the homogeneous part now, which is y double dash plus 25 y is equal to 0. Solution of this is this. So I am going to write a characteristic equation, auxiliary equation, which is lambda square plus 25 is equal to 0. So that will give me lambda is equal to plus or minus 5i. So the general form of lambda is a plus ib, a plus or minus ib. So by comparing these two, we can conclude that b is equal to 5. So as we all know, the general solution y1 of t, actually y1 of t can be written as e to the power ax into c1 cos bt, and y2 of x is equal to e to the power ax into c2 sin bt. So a is equal to 0, as we know. We can conclude that as we already concluded, a equal to 0 and b is equal to 5. So this will be 1 into c1 cos phi t is equal to c2 sin phi t. So the general solution, the solution of this homogeneous part is c1 cos phi t plus c2 sin phi t. So this is the homogeneous solution of homogeneous part. So let's solve this one, this part now. Turn the page. So the solution of that part, write the equation again. Y double dash plus 25y is equal to 24 sin t. Let's I'm going to solve this particular solution by the method of undetermined coefficients. So which is, I'm going to write some form of equation. Let us assume as the solution of form sin omega t plus v cos omega t. Here omega doesn't represent the angular frequency. Here this omega represents the frequency of sinusoidal force. That omega represents this omega. Here the sinusoidal force. Here the force is not constant, right? So now from the question itself, we can observe that omega is equal to 1. So I am writing it as a sin t plus b cos t. So y dash will be a cos t minus b sin t. Y double dash will be minus a cos t, so minus a sin t minus b cos t. I'm going to substitute these values here in this equation. So minus a sin t minus v cos t plus 25 into a sin t plus b cos t is equal to 24 sin t. So by adding these two terms, you will get 24 a sin t plus 24 cos t is equal to 24 sin t. So by comparing the LHS and RHS, we will get a is equal to 0, and there is no cost term here. So b will be 0 and a will be 1, because by comparing these two equations, we will get LHS and RHS, we will get a is equal to 1 here. So in the solution, y particular will be a sin omega t. Here a is 1 plus b is equal to 0, so this doesn't matter. So yp will be sin t. So the solution of that equation is y is equal to, a homogeneous part solution is c1 cos phi t plus c2 sin phi t plus particular solution is sin t. So now I'm going to use these given conditions here. Here they are given y of 0 is equal to 1. So I'm going to substitute here. 1 is equal to c1 into cos phi of 0 will become 1, c1 plus c2 into 0, sin 0 will be 0 plus here sin 0 will be 0 again. So c1 is equal to 1. Now I'm going to substitute y dash of 0 is equal to 1, which is given in the question itself. So y first first let me find y dash of t, which is minus c1 minus 5c1 cos phi t plus 5c2 cos phi t plus cos t. So y dash of 0 will be 1, it's given in the question, y minus 5 c1 is 1, we got that already, so 1 into cos of 0 will be 1 plus plus 5c2 into I forgot, I mistakenly write it as cos phi t. It's actually sin phi t, right? So this will be 0 by substituting t is equal to 0. So 5ct c2 plus cos of 0 will be 1. So that will give me 5c2 is equal to 0. c2 will be 0. So by we have obtained these two results, so I am going to substitute these in this solution. So that will be y is equal to c1 is 1, which we got in by solving, so cos phi t plus c2 equal to 0, so that will be 0 plus sin t. So this is the solution of that given differential equation. So this is this describes the position of that mass of that spring mass system. So we were asked to find out, we were asked to sketch the graph of the solution curve and the graph of the y and graph of y is equal to yp. So let me draw the graph of y is equal to yp now. So y is equal to yp is sin t, which we got sin t. So I'm going to draw a sin t graph now. So as we all know, sin t graph, sin starting from 0 and the sinusoidal wave. So actually this is sin t graph, but t will be always positive. So t is equal to 0, it is a time where we started observing the mass system. So this will be the part here. This is 0, this will be pi by 2, and this is pi 2 pi. So its period will be 2 pi. So let me sketch the graph of this part. The solution y is equal to cos phi t plus sin t. This will actually last, it won't contract. There will be no steady state in this condition, because there is no damping constant, or there isn't anything that is going to reduce the value of y. So there will be no steady state or something like that. So it will last throughout the till time is equal to infinity. I did a mistake here. So let's find out the period of this function first. This will be 2 pi by 5, LCM of 2 pi by 5 and 2 pi by 2 pi, which is 2 pi, which is the period of this function. So let me draw the sine graph first. This will be of this form. So and sin t plus cos phi t. So at every particular point there will be a cos phi t term adding upon it. So if it is cos phi t will be this. So its solution will be something like this. So at every point it adds cos phi t term will add upon sin t term. the graph is a bit complex to draw it on a paper, so I'm showing in this app. See, you can observe this. This is a sin t plus cos phi t graph. So its period is 2 pi. You can observe it from minus 5 to plus 1, something around 1. So it is 2 pi. It is something like 6.28, so which is 2 pi. So we can also observe that it's not, its frequency is not changing at all. So because there isn't any damping constant, this is not damping. So this will last till infinite. So there is nothing like a steady state in this equation. So that's it. Hope you understand my explanation. Thank you.